Okay, in this video, in this section, we're going to be looking at the mean value of z function. Okay, so the idea behind the mean value would be to draw some axes, first of all. I've got my left and right axes, or my y and x, whatever you would like to call them. And I've got some function. It could be a wavy function, it doesn't really matter. It kind of goes up and can come back down if you really want to. So, something like that. And it is to do with finding some points. So let's pick that point out there, very bad line. But that will be point A, and I could pick out another point, point B. And you know from your work on integration, which is why it's an integration section, that it will be the integral between A and B of y equals some function of x in respect to x. Okay, that's the idea. Now, with a mean value, we're trying to find, if I draw in a rectangle, for example, about here, call that some h, okay, and I could have my very nice little height there. Now, you can tell me the area of that rectangle, can't you not? Well, you know the area would be base, which is b minus a, times the height. So this is b minus a, just times the height. Okay? Now, if you want to get the height, which is what you'll be looking at in this section, well, the height will just be that, so it'll be 1 over b minus a times the integral between a and b of f of x dx. Okay, so the area in here is modified by that, which is then in turn using this to find the height. Okay, and this is in second year, so those of you who are doing AS don't need to know this, but if you're doing the full A level, you do need to know this stuff, which is why I put it in my integration section. Okay, so that's what we're going to be exploring and looking at in this section. Okay, so this is this example then. So find the mean value of f of x is equal to root x in the interval 2, 4. Now, we explored in the last part of this video that 1 over b minus a times the integral of in between the limits of sum of the function of x in respect to x. So we need to do 1 over, now b minus a will be 4 minus 2, which we'll get us a half, we'll simplify in a minute, between 2 and 4 of root x. Now root x, I'm going to prepare the vegetables, get us x to the half dx. Okay, make sure I get my arrow in. Or 1 over 4 minus 2, as I just said, will get me a half times the integral. Now, I don't have to do the integral. I'm going to do the integration now, just to make sure it's pretty easy. And we get this done. Get 2/3 x to the 3 halves, adding 1 to the power divided by the new power. And I evaluate between 2 and 4. Now, the next stage is just substituting in, right? So, I'm going to bring the half out the front of, now, 4 to the 3 halves, well, that'll be 8 times 2, which should be 16 over 3. Okay, take away, well, that's going to be root 2 cubed times 2/3, so that is 2 root 2 over 3. Don't forget I'm still times by half. Okay. Well, it won't be that before root 2, won't it? Simplifying root 8. So multiplying through by the half, and I get 8/3 minus 2 root 2 over 3. And you could, if you want, factor 2/3 out. I mean, you don't have to, but it would look nice. And you end up with that. So any of those would be accepted. Okay, and that's how I can do this question. Okay, another example then. find the mean value of f of x is equal to x cubed minus 3x plus 2 in the interval between minus 2 and 2. Okay, well, as you've just seen in the previous section, I've got the 1 over b minus a times the integral between a and b of fx dx. That's the formula that I'm going to be using. So I've got 1 over 2 minus minus 2, so the integral between minus 2 and 2 of x cubed minus 3x plus 2, and that's in respect to x. Okay, 1 over 2 minus minus 2 will give me 1 over 4. I'll integrate immediately, so it'll be 4, bring the power down, so it'll be 1/4 x to the 4. Now that'll become minus 3 halves x squared, won't it? And that'll become 2x. Evaluated between minus 2 and 2. Okay, now I'm going to substitute in. I'm going to get 4 minus 6, okay, plus 4 as well. I'm going to minus the other bracket, which will be 4, is it minus 6? Yeah, it's minus 6. Got to go minus 4 as well. So I get that. Evaluate that. Well, I get 1/2 of 2 plus 6. Well, 2 plus 6 will give me 8 times 1/4, which will be 2. Okay? And that is how I can answer this question. Okay, so in this part of the video, we're going to be looking at the mean value of f of x equals sine x in the interval 2 pi over 3 to 5 pi over 6. Okay? Remember, these are in radians, so make sure you've done radians before you move on to this part of the section. Okay? I've got 1 over b minus a, which is 5 pi over 6, take away 2 pi over 3, times the integral between 2 pi over 3 and 5 pi over 6 of sine x dx. Okay. So 5 pi over 6 take 2 pi over 3, well, common denominator will be 6. So 5 pi take 4 pi, which gives me pi over 6. But 1 divided by that will flip it, so it'll be 6 over pi, won't it? Don't know how that works, you need your fractions knowledge to be quite on point here. Between 2 pi over 3 and 3 pi over 6. Okay? Of sine x dx, which will be 6 over pi of minus cosine. Integral of sine is minus cosine. Okay, by the way, it is between 2 pi over 3 and 5 pi over 6. Okay, so substituting in, don't need my calculator, no, I'm not using my calculator for this bit. 6 over pi, lots of 5 pi over 6, well, minus cosine is the same as cosine of pi over 6, which is 3 over 2 from memory. Memorising the triangles, yeah, it's important. And 2 pi over 3, well, 2 pi over 3 is 2 lots of 180, so it'll be 120, which is a half. Okay, so we can factorise the half out, so it'll be 3 over pi, won't it? Okay, and then I have to factorise that to root 3 over 1, 3 minus 1. Yeah, alright. You'll check me in the comments anyway. But there you go. That is how I can find the mean value of sine x in the interval given in radians. Okay, so I've got a different type of question for you. I've got the mean value of f of x is 2x plus 5 in the interval a b is 13. And the interval a3b is 25. Part A. Find the values of A and B. Okay, this is a mouthful, but there's 2 stages I want to do it. Okay, well, there's two real stages. Okay, so we've got, I'll do the second one bit here because that might be a bit more helpful to me. So I've got 1 over 3b minus a, okay, times the integral between a and 3b, okay, remembering you put the limits the right way around, of 2x plus 5 dx is 25. Okay, that's the first step that I want to do. Then I'll integrate. So 2x will integrate to x squared, and I get 5x because any constant term will just gain. And x evaluated between a and 3b, 1 over 3b minus a, which is still 25. Okay, this is quite a mess, this question. Got 1 over 3b minus a. Now, I need to substitute in, so I get 3b all squared, which will give me the 9b squared, don't forget to square the 3, plus 15b through. Then I want to take away a squared, don't forget it's a takeaway, take on each limit, and 5 lots of a becomes a minus 5a, and that will be equal to 25. Okay, remember that's in a bracket. I don't know, when you subtract your limits, you put them in brackets, yeah? Now, I think that'll factorise, won't it? I think it will. I can bring out this factor, 3b minus a. And I can try and cancel some things. So I'll get 3b. That'll have to be a plus a, won't it? To make the a squared. The minus a squared. I'll have to add 5. Now, these are very nice, because these will cancel, which is quite nice. So I get a 3b plus a plus 5. Okay, funnily enough, that's going to be equal to 25. So I get 3b plus a is 20. I'm going to call that equation 1. Okay, you can see where I'm kind of going with this. And I've got 1 over, the other one, so b minus a, times the integral of a and b of 2x plus 5 dx, and that will be equal to 13. See where I'm going with this now. So I get 1 over b minus a, integrating, I get x squared plus 5x, by the way, it's between a and b, still equal to 13. Then I get, substituting in the b first, so I get b squared plus 5b, b squared plus 5b, okay, minus a squared minus 5a is 13, don't forget I need to carry that 1 over b minus a, because it's the mean value that we want here. But I have to bring out the b minus a factor again, so I'll get b, now is it b, be a plus a1 and a plus 5, and that'll be equal to 13. And that 1 over b minus a will continue. So they'll cancel, so I get b plus a plus 5 is 13, so I get b plus a will be equal to 8. Okay, so I've got 2 equations, equation 1 and equation 2. I like to use a method of substitution, like many teachers out there. So rearranging that one, I'll get myself, let's find a first. So we'll do a equals 8 minus b. So we'll do 3b will be equal to, not 3b, b, 2b. 2b is equal to 12. 2b is equal to 12. So b is 6, yeah? Well, if b is 6, well, a is 8 minus b, which implies that a is 8 minus 6, which is 2. Okay, and those are my 2 values. It's a long question, but it can definitely be done using simultaneous equations and your mean value knowledge. I've just taught you through. Okay, that is how I can do this problem. Thank you so much for watching this video right through to the end. That's the end of the mean value stuff. I'm going to move on, and next up we're going to be looking at series, roots of polynomials, complex numbers, all that kind of stuff. It won't be teaching like this, it'll be teaching from the PowerPoint, as you've seen for the linear transformations video that I put the other day. Feel free to like, comment, subscribe on all these videos that I've made in the past, as well as all these that I'm making now. So this is the last little bit of integration that you'll see when these videos are in order. This is the last bit you will see, and then we're going to move on and we're going to start looking at some more intriguing looking questions, but they are quite nice. Okay, so thank you very much, and Mathboy will now be out of here. Thank you.